Hi guys, this is Chapter 5, the integumentary system. And as always, if you have any questions about the material, feel free to ask me during class. First, the skin and all of its appendages, like sweat glands, sebaceous glands, hair, and nails, make up the integumentary system. The integument is an organ, and it is the largest of all organs in the body, accounting for 7% of all body weight. Remember, an organ consists of more than one tissue working together to perform a certain function. The integument system has many functions in the body. It protects us from abrasive materials. It is a non-specific immune response in that it provides a barrier from infections, and the melanin in our skin is our own personal UV protection. Our skin also prevents unnecessary water loss from the body's surface. The capillary beds in the dermis can also vasoconstrict or vasodilate to retain more body heat or emit body heat, respectively. Our skin also has sensory receptors that are associated with nerve endings, and these provide us with clues about our environment. When we say the word skin, we are really referring to two layers, the epidermis and the dermis. The epidermis is keratinized stratified squamous epithelium. The dermis is just deep to the epidermis, and this is where you will find sweat glands, hair follicles, sebaceous glands, and capillary beds. The hypodermis is also called the tela subcutanea or superficial fascia. This is the largest reservoir of adipose tissue in your body. Technically, this layer is not part of the integumentary system, but due to its proximity to the integument, it is usually taught along with the integument system. The epidermis is an avascular, keratinized stratified squamous epithelium. There are 4 distinct types of cells listed here. Keratinocytes are the most abundant cell type and produce keratin. Keratin is a tough, fibrous protein. The keratinocytes are born from a layer called the stratum basale, where they undergo rapid mitosis. As new keratinocytes are born, the daughter cells are pushed upward to the next layer of the epidermis. By the time they reach the surface of our skin, they are dead and are basically sacs of keratin. Every 35 to 45 days, our entire epidermis is renewed, and we lose about 40 pounds worth of skin cells in our lifetime. Wouldn't it be great if we can do that all at once in one day? Sweet! Merkel cells are distributed among the keratinocytes and are associated with nerve endings, are likely touch receptors. Let me do that sentence again. Merkel cells are distributed among the keratinocytes and are associated with nerve endings and are likely touch receptors. Melanocytes produce melanin and then transfer it to the keratinocytes. The melanin then clusters on the superficial side of the keratinocytes to shield the nucleus and DNA from the UV light. I studied UV radiation damage on DNA, and it causes bulky photoproducts and cross-links in the DNA, and if these aren't repaired correctly, it can lead to cancer. We all have the same number of melanocytes. The difference in skin color from melanin is due to the rate of melanin removal by the keratinocytes. Those of you who are pale skinned, your keratinocytes have a high degradation rate of melanin. If you are darker, then your keratinocytes don't digest the melanin as quickly. Lastly, Langerhans cells are among the keratinocytes too. These are a class of dendritic cells. They are very similar to macrophages, which you will learn about in the blood unit. Basically, these cells act as a non-specific immune response. They engulf large foreign proteins, or antigens, and then activate other parts of your immune system to come fight against an invading organism. Now I'd like to cover the layers of the epidermis. Thick skin has 5 layers, or strata, which means bed sheets. In thin skin, there are only 4 layers. The layers from deep to superficial are the stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, which is in thick skin only, and stratum corneum. I'll talk about each one specifically. Here is a cartoon drawing of 4 of the 5 layers. Because we only see 4 layers, we can assume we are not dealing with thick skin. If we were talking about thick skin, as found on the palms of our hands and soles of our feet, then there would be a 5th layer called the stratum lucidum between the granulosum and corneum layers. First, let me talk about stratum basale. This layer is attached to the dermis just deep to it, and is also called the stratum germinativum, or germinating layer, because it is in this layer where the keratinocytes are rapidly dividing and creating daughter cells that keep getting pushed upwards through the more superficial layers. Notice here is where we find melanocytes and Merkel cells. Next is the stratum spinosum, or spiny layer. This layer is several layers thick, and mitosis is still occurring, but at a slower rate. This layer gets its name mainly because of an artifact during tissue preparation. The cells really do not have spines on them when they are living. The keratinocytes in this layer make a pre-keratin protein that resists tension. Also found in this layer are the Langerhans cells. Next is the stratum granulosum, or granular layer. Here we have about 1 to 5 layers of flattened keratinocytes. The next layer I want to talk about is the stratum corneum. The stratum corneum is also called the horny layer, or sometimes referred to as the cornified layer. This is the most external part of the epidermis, and it is many cells thick. It is much thicker in thick skin than in thin skin, and its dead keratinocytes are flat sacs completely filled with keratin because their nuclei and organelles disintegrated upon cell death. Keratin consists of tonofilaments embedded in a glue-like substance from the keratohyalin granules. Both the keratin and the thickened plasma membrane of cells in the stratum corneum protect the skin against abrasion and penetration. Additionally, the glycolipid between its cells keep this layer waterproof. The layer that would be found between the stratum granulosum and stratum corneum in thick skin is the stratum lucidum. This is called the transition zone, and it appears as a light translucent band and is a few cell layers thick. Again, it is only found in thick skin, which is found on the soles of your feet and the palms of your hands. And it really is a beautiful layer that we will see histologically when we view the layers of skin, thick skin specifically, underneath a microscope. Deep to the epidermis is the next layer of the integumentary system, called the dermis. It is basically connective tissue, and it is highly vascularized. That means it has a lot of capillary beds, and very innervated. The capillary beds that are found in the dermis help with thermoregulation. When it is a very hot day and you need to get rid of some body heat, your capillary beds in this layer can vasodilate and allow more heat to radiate off your body. If you were very cold and you needed to retain your body heat, then these capillary beds would vasoconstrict. When someone is wearing a leather jacket, it is really constituted from the hide of the animal, which is basically this layer. So next time you are at a party and you see someone wearing a leather jacket, you can now say, "Nice cow dermis." In this layer, we are going to talk about 2 layers called the papillary and the reticular layers. The papillary is the most superficial layer, and the reticular layer is the most deep layer of the dermis. I'd like to now talk about the papillary layer of the dermis. This is the most superficial layer of the dermis and represents 20% of the overall dermal layer. It consists of loose areolar connective tissue with thin collagen and elastic fibers. It also includes the dermal papillae, which are finger-like projections that extend into the overlying epidermis. These projections of the dermal papillae into the epidermis increase the surface area for exchange of gases, nutrients, and waste products between these layers. Remember that the epidermis is avascular, and thus the keratinocytes depend heavily on the diffusion of waste and nutrients from the underlying dermis. Their interdigitation of these layers also strengthens the dermal-epidermal junction and reduces blister formation. On the palms of the hands and the soles of the feet, the dermal papillae lie atop larger mounds called dermal ridges. These elevate the overlying epidermis into epidermal ridges or friction ridges, which create fingerprints, palm prints, and the gripping ability of the hands and feet. Patterns of these ridges are genetically determined and unique to each person. Because sweat pores open along the crests of the epidermal ridges, they leave distinct fingerprints on almost anything they touch. Thus, fingerprints are really sweat films. And yes, some people actually genetically lack fingerprints, and actually not just fingerprints, but I should say friction ridges, and they have a hard time turning pages in a book or grasping things because they lack these dermal ridges. The deeper layer of the dermis is called the reticular layer, and this comprises 80% of the overall dermal layer. It is composed of dense, irregular connective tissue, and the extracellular matrix contains thick bundles of interlacing collagen and elastic fibers that run in many different planes. Separations or less dense regions between the collagen bundles form the lines of cleavage, and I'm not talking about those that you would find on Pamela Anderson. Rather, these are invisible lines that occur over the entire body. They run longitudinally in the skin of the limbs and head and in circular patterns around the neck and trunk. A knowledge of cleavage lines is very important to surgeons. Incisions made parallel to these lines tend to gap less and heal more readily than incisions made across the cleavage lines. Extreme stretching of the skin, as occurs in obesity and pregnancy, can tear the collagen in the dermis. Such dermal tearing results in silvery white scars called striae, which we know as stretch marks. Just deep to the skin is the fatty hypodermis. This layer, as I said before, is also called the superficial fascia, or the subcutaneous layer, or tela subcutanea. The hypodermis consists of both loose areolar connective tissue and adipose connective tissue, but adipose tissue is the most predominant tissue type. Besides storing fat, the hypodermis anchors the skin to the underlying structures, mostly to muscles, but loosely enough that the skin can slide relatively freely over those structures. The hypodermis is also an insulator because fat is a poor conductor of heat. It helps prevent heat loss from the body. The hypodermis thickens markedly with weight gain, but this thickening occurs in different body areas in the two sexes. In females, subcutaneous fat accumulates first in the thighs and breasts, and this is called gynoid fat. It is just too bad, ladies, that we can't be selective as to where the fat gets deposited, because I, for one, would like to eat a couple of hamburgers and fill out my cocktail dress a little bit better. In males, the fat accumulates in the anterior abdomen as the, quote, beer belly, and this is called mastoid fat. Along with the skin itself, the integumentary system includes several derivatives of the epidermis. These skin appendages include nails, hair follicles, sebaceous glands, and sweat glands. Although they derived from the epithelial cells of the epidermis, they all extend into the dermis. A nail is a scale-like modification of the epidermis. Like hairs, nails are made of hard keratin. Each nail has a distal free edge, a body which is the visible attached part, and a root, which is the proximal part embedded into the skin. The nail rests on a bed of epidermis called the nail bed. At the root, in the proximal end of the nail body, the bed thickens to form the nail matrix, the actively growing part of the nail. The matrix is so thick that the pink dermis cannot show through it. Instead, we see a white crescent called a lunule. The lateral and proximal borders of the nail are overlapped by skin folds called nail folds. The proximal nail folds projects onto the nail body as the cuticle or epinecium. A hair is a flexible strand made of dead keratinized cells. The chief parts of a hair are the root, the part embedded into the skin, and the shaft, the part that projects above the skin surface. A hair consists of 3 concentric layers of keratinized cells. There is an inner core called the medulla, the cortex surrounding the medulla, and lastly the outmost cuticle. Hair conditioners smooth out the rough surface of the cuticle to make the hair look shinier. Hair follicles extend from the epidermal surface to the dermis. The deep end of the follicle is expanded, forming a hair bulb. A knot of sensory nerve endings wraps around each hair bulb to form a hair follicle receptor, or root hair plexus. Bending the hair shaft stimulates these nerve endings. Hairs are thus very exquisite touch receptors. A nipple-like bit of the dermis, called the connective tissue papilla, or hair papilla, protrudes into each hair bulb. This papilla contains a knot of capillaries that deliver substances that stimulate hair growth and supply nutrients to the growing hair. If the hair papilla is destroyed by trauma, the follicle permanently stops producing hair. If the epithelial cells in the hair bulb just above the papilla make up the hair matrix. The wall of a hair follicle is actually a compound structure composed of an outer connective tissue root sheath derived from the dermis and an inner epithelial root sheath derived from the epidermis. The epithelial root sheath has 2 parts, an internal root sheath and an external root sheath. Associated with each hair follicle is a bundle of smooth muscle cells called an erector pili muscle. The contraction of this muscle in response to cold or fear causes the hair to stand erect and dimples the skin surface to produce goosebumps. And by the way, we will view all of these structures underneath the microscope, and they will become more clear to you. There are many different types of glands associated with the integument system. I'd like to first talk about sweat glands. Sweating prevents overheating of the body because sweat cools the skin as it evaporates. Only mammals have sweat glands. And sweat is an unusual secretory product in that it is primarily a filtrate of blood, and it is 99% water with some salts and metabolic waste. It is acidic, so it also retards the growth of bacteria on the skin. There are 2 types of sweat glands, and this is some of my most favorite stuff, both of which increase their secretion in response to stress as well as to heat, eccrine and apocrine. The eccrine glands are by far the most numerous type and produce true sweat. They are most abundant on the palms, soles, and forehead of the body. Apocrine glands are mostly confined to the axillary, anal, and genital areas. They are larger than eccrine glands, and their ducts open into hair follicles. Apocrine glands produce a special kind of sweat consisting of fatty substances and proteins in addition to the components of true sweat. For this reason, apocrine sweat is viscous and sometimes has a milky or yellow color. This product is odorless when first secreted, but as its organic molecules are decomposed by bacteria on the skin, it takes on a musky smell. This is the source of body odor. The secretions from the apocrine glands were identified as true human pheromones. These are chemical signals that convey information to a member of the same species. In the late 1990s, it was shown that they are responsible for the synchrony of the menstrual cycle that occurs in females who live together. And I already told you, or maybe I didn't, about that experiment where they took the secretions and wiped it on the upper lips of the females. The skin also has some modified sweat glands like the ceruminous glands, which are found in your external ear canal and secretes earwax. Those are modified apocrine glands. The mammary glands are also specialized sweat glands that secrete milk. Sebaceous glands are the skin's oil glands. They occur over the entire body except on the palms and the soles of the feet. Their oily product, called sebum, is secreted in a very unusual way. The cells become so engorged with the oily lipids that they burst apart. This process is called holocrine secretion because whole cells break up to form the product. Most sebaceous glands are associated with hair follicles, emptying their sebum into the upper third of the follicle. The secretion of sebum is stimulated by hormones, especially androgens, which is a male steroid hormone. When a sebaceous gland becomes blocked by sebum, a whitehead appears on the skin surface. If the material oxidizes and dries, it darkens to form a blackhead. Blocked sebaceous glands are likely to be infected by bacteria, producing a pimple. The bacteria break down the sebum into irritating fatty acids, and this will lead to inflammation, especially when the entire infected mass bursts out of the follicle into the surrounding dermis. Inflammation is associated with redness and heat. I, for one, like to pop my clogged sebaceous glands and watch that white stuff splatter all over the mirror. Super fun. Burns. A burn is tissue damage inflicted by heat, electricity, radiation, extreme friction, or certain harmful chemicals. The immediate threat to life from serious burns is a catastrophic loss of bodily fluids, primarily through inflammatory edema, and in physiology you learn a lot about edema. The fluid that seeps from the burned surfaces and the fluid seeps from the burned surfaces, and the body quickly loses water and essential salts. This dehydration in turn leads to fatal circulatory shock, that is, inadequate blood circulation caused by the reduction in blood volume. To save the patient, the medical team must replace the lost fluids immediately. After the initial crisis has passed, infection becomes the main threat as pathogens can easily invade areas where the skin barrier is destroyed. Burns are classified by their severity or depth as first, second, or third degree burns. Third degree burns are the most severe. In first degree burns, only the epidermis is damaged. Symptoms include redness, swelling, and pain, the typical inflammatory reaction to tissue damage. Sunburn is usually a first degree burn. Second degree burns involve injury to the epidermis and the upper part of the dermis. Symptoms resemble those of first degree burns, but blisters also appear as fluid accumulates between the epidermal and dermal layers. First and second degree burns are considered partial thickness burns. Third degree burns consume the entire thickness of the skin, and thus are full thickness burns. The burned areas appeared white, red, or blackened. Although the skin might eventually regenerate, it is usually impossible to wait for this because of the severe fluid loss and infection. Therefore, a graft is taken from the patient's body and put on the burned area. This is called an autograft, as in not the kind that you write on a piece of paper, but autograft spelled G-R-A-F-T. Basal cell carcinoma is the least malignant and most common of the skin cancers. Over 30% of all Caucasians get it in their lifetimes. Cells of the stratum basale proliferate, invading the dermis and hypodermis, and causes tissue erosions there. The most common lesions of this cancer are dome-shaped, shiny nodules on sun-exposed areas of the face. These nodules later develop a central ulcer and a pearly beaded edge. They often bleed. Basal cell carcinoma grows relatively slowly, and metastasis seldom occurs. Full cure by surgical excision or other methods of removal is the rule in 99% of the cases. Squamous cell carcinoma arises from the keratinocytes of the stratum spinosum. The lesion appears as a scaly, irregular, reddened papula or small, rounded elevation that tends to grow rapidly and metastasize if not removed. If treated early, however, the chance of a complete cure is good, and the overall cure rate is 99%. The carcinoma can be removed by radiation therapy, by surgery, or by skin creams containing anti-cancer drugs. A melanoma is a cancer of melanocytes and is the most dangerous kind of skin cancer. Because melanoma cells metastasize rapidly into surrounding circulatory vessels, the key to surviving melanoma is early detection. Most people do not survive if their cancer is about the size of an eraser head. Melanoma is resistant to chemotherapy and current immunotherapy treatment, although vaccines are being created or tried. Melanoma can originate wherever there is a pigment, but often arises from existing moles, usually appearing as an expanding dark patch. The American Cancer Society suggests that individuals with frequent sun exposure regularly examine their skin for moles and new pigment spots, applying the ABCD rule for recognizing melanoma. A stands for asymmetry. The two halves of the spot or mole do not match. B stands for border irregularity. The borders have indentations and notches. C stands for color. The pigment spot contains several colors, including blacks, browns, tans, and sometimes blues and reds. D stands for diameter, larger than 6 millimeters, larger than a pencil eraser. Some experts have found that adding an E for elevation above the skin surface improves diagnosis, so they use the ABCDE rule. This concludes our integumentary system lecture. Goodbye, and be sure to read the chapter. As always, we'll be discussing this material in lecture.